All right. So we will be discussing triangulation, and in that, first thing is what is triangulation, and then we will discuss objectives of triangulation and what is the principle of that. Then we will see different systems or figures that we will be using in triangulation, and then there is classification. You will see that for different if for different proportion of the land, there are different systems, right? And then we will at the end we will also discuss one example. So what is triangulation? In triangulation, what we do is that basically, let's say, as you can see in this figure, let's say if we consider this figure, so we measure only a few sides and the rest of the angles, and then using that known sides and the angles, we determine the lengths of the rest of the sides of our traverse. For example, let's take this as an example. If there is a river and on the other side of a river there is a tree, right? And you have to measure measure the distance between let's say point A and the tree, right? So what you're going to do is that let's say you will select 2 points on the same side of the river. Let's say in this case you have selected point A and point B, right? Now what you will do is that now you are not able to measure the distance between point A and the tree because there is river in between and you are not able to measure that. Now, how can you measure that? We can measure that easily if we consider 2 points. For example, here we have considered 2 points, point A and point B. They are on the same side of the river and we are able to determine the distance between point A and point B since they are on the same side of the river. So what we are going to do is that we will, by standing at A, right, we will plot a ray that will be an imaginary ray. We will measure the angle from point A to the tree, right? And similarly, by standing at point B, we can measure the angle of the ray that is from this baseline to that tree. So we know that if in a triangle, we know two angles, we can easily determine, and one side, we can easily determine the remaining parameters. For instance, over here, we know the distance AB, right? And the distance from A to the tree, that is the distance from A to the particular object, that is unknown. So since in this triangle, we know two angles and one side, we are able to determine the length of the other sides of the triangle. So this is the basic idea behind triangulation, that we measure limited sides and we measure rest of the angles, and then using that principles of trigonometry, we are able to determine the length of the rest of the sides. So this is basically explained over here, that by using available data, that is by using the limited number of sides and the rest of the angles in a given geometry, we are able to determine the different length of different traverses using the principles of trigonometry. Now, what are the objectives of the triangulation? The objectives of the triangulation, there could be a number of that. For instance, to establish accurate control points for plane and geodetic surveys. We have already discussed this thing, that what is plane survey and what is the geodetic survey in survey 1, right? So if we have to establish the control points are those points which control our work when we are in the field. We establish some control points and then we proceed from those. So if we have to establish our control points in geodetic or plane survey, we can use that. We have already discussed the thing that plane survey, the curvature of Earth is not considered. In geodetic survey, the curvature of Earth is considered, right? And then to establish control points for photogrammetric surveys, right? For instance, you are doing a photographic survey in which you take photographs from the top, right? And then from by judging those photographs, you have to establish your control points. Okay? This could be any permanent features. For instance, it could be a bridge, it could be an electrical pole, it could be any permanent feature that you think will serve you good when you will be doing the survey in the field. And if you have to determine the shape and size of the earth, for that also you can use the triangulation. That is, you divide the entire globe into a system of triangles, and then by using laws of trigonometry you are able to determine both say shape and size of the earth. And similarly, if you have to establish control points for your engineering works, like you are doing a survey for a road,
we're really hitting the big top.
for that you can use this triangulation, right? If there is some other project, like if you have to construct a certain a bridge or any other mega project, or any other project, for instance could be a survey system. If you have to establish some control points, for that you can use this technique. So this technique has a number of applications depending upon what is the purpose of your use. Then the classification system. The classification system is based upon the area that needed to be covered. The first order or primary classification, in that if you have to cover a wide area, like for instance if you have to cover the entire area of a country like Pakistan, then you will go for primary, first order classification, right? What is secondary classification? Suppose you have to go for a smaller area, for instance you have to go a particular province of Pakistan, then you will go for secondary classification. And third order, your tertiary classification, is that if you have to go for a specific project, right? uh, like it could be a survey system, it could be a road network between inside the province, then you will go for the third order classification. So these are the three types of classification. Depending upon your area, you will be selecting any of these of three. Now this is a table that is giving you the basic information about the three systems. Like for instance, if it is the first order triangulation, then the length of the baselines, they will be from 8 to 12 kilometers, since in first order triangulation we cover larger area. And if it is second order triangulation, then it is 2 to 5 kilometers. Similarly, the third order, that is specific for some engineering project, that is smaller area, and the baseline length will be further smaller. So these are different guidelines that you can follow while performing the triangulation survey in the field. Then different figures that you can use is, you can use triangles, single chain triangles, double chain triangles, as you can see over here, single chain of triangles. Then we have double chain of triangles. Then we have brace correlators. Then we have center triangles and polygons. You can use any of these. There is a grid system or central system. You can use go for this system as well. No, there are some basic considerations while considering these systems, right? Uh, no, simple triangles should be preferably equilateral, ठीक है जी? और जो बेस कोऑर्डिनेटर्स हैं वो प्रेफरेबली होने चाहिए स्क्वायर्स में होने चाहिए. अब बेसिक आइडिया ये है, whenever you have to divide your system, suppose if you have to perform a survey at a certain pace using this triangulation technique, you have to divide your area in such a way that you will be able to do the computations through two different routes. We will discuss this thing at the end. Remember this point, that you have to divide your area in such a way that you can do the calculation through two different routes, right? Uh, Keep this thing in mind, and when we will be discussing that example, this will be further clear over there. And our arrangement should be that our route should be consisting of well conditioned triangles. ठीक है? अब हमने डिस्कस किया, you could be using simple triangles, quadrilaters, polygons, and when you will be dividing your area in these respective figures, there are few considerations that you need to consider. The first is that for simple triangles, the angle should not exceed 45 degrees. And in case of quadrilaters, none of the angles should be less than 30 degrees. In case of certain polygons, the centered polygons, or the angle should not be less than 40 degrees. No, these are the guidelines, right? Now, uh, why is we have to divide our area into these well-conditioned triangles? Uh, the reason is quite simple for that. Since we are measuring the angles and a limited sides, right? So uh, if we will be making our well-conditioned triangles, then since from angles we will be and once a few sides will be computing the next sides that will be there in the traverse. So if we have divided our area into well-conditioned triangles, the chances of our error are minimum. So any error in angular measurement has a minimum effect upon the uh, computed lengths. To ensure that two sides of a triangle are equally affected, these should be equal in length. Okay? The concept is that if there is an error, that error is uniformly divided between all the sides of a triangle, right? So the chances, so the error will be minimum in that case. So since we want to divide the error equally, so it is preferred that the two sides should be equals. So it means that the triangles, they should be isosceles. Okay. So we have been discussing this well-conditioned triangle, and we already know this thing from our previous knowledge that a well-conditioned triangle is that in which none of the angles is lesser than 30 degree, or uh, it should not be more than 120 degree. So this is the general guideline for a well-conditioned triangle. Now, the thing I was telling you that you should divide your network in such a way that you should be able to perform the calculation by at least two different routes, right? Now, what is strength of the figure? Uh, the strength of the figure is basically a concept that helps you in determining the best possible route that will give you the minimum error. अभी क्या कहते हैं, a figure which gives the least error in the calculated length of the last line in the system due to the shape of the triangles and the composition of the figures. The basic idea is that, let's suppose you have divided a certain area in triangles, and let's say there are two possible routes, let's say A and B and C and D, right? Now he says that if at the end of your work, right, the last line that you computed by using both these routes, both the channels, if the route that gives you the minimum error in that, let's suppose at the end there was a line that by after following route AB, and it comes out to be 4 meter, and after following route CD it comes out to be, let's say, 4.9 meters, right? Now when you will be actually measure that length at the end, let's say the actual length comes out to be 4 meters, so it means that the route AB was correct, it has given you lesser error. So he says that that route is the best possible route, right? Now there is a way how can we determine the best possible route for any system. We will see that in a while. Now since we have discussed the triangles, they should be well conditioned. The reason is that sine they think more rapidly for smaller angles than for larger ones. So it is evident that the percentage error in the computer side of a triangle that will be opposite to the smaller angle that will be larger as compared to the larger angle. So this is the basic idea behind that. So uh, that is why we go for the well conditioned triangles. Now we have to determine the R value if we want to determine the strength of any figure. Now what is this R value? This R value is called the shape factor. Now this shape factor helps you out in determining which is the best possible route for any given survey. For instance, this R value that can be calculated by d minus c over d summation of delta A square into delta A delta B plus delta B square. Over here, what is the, now this thing is important over here. D is the number of directions observed excluding the known side of the figure. ठीक है जी. Let's say there was a triangle ABC, right? Now we have three sides in that, right? Now we say that the side AB is known to us. Then the side that is not known to us will be the other two sides, right? So D is the number of directions observed excluding the known side of the figure. So if he told us that he has observed all the three sides of the triangles in both directions, right? Then how can we calculate the value of D? That we will see in a while when we'll be using examples. And delta A and delta B and delta C, these values that you can obtain from a table that is given below. No, the C, this is that is used in this relationship D minus C. अब C की value को कैसे calculate करना है? C is equal to n dash minus s dash plus 1 plus n minus 2s plus 3. ठीक है. अब यहाँ पे n क्या है? N is the total number of lines including the known side in a figure. Suppose they are in a triangle, there are three sides. Okay, and one of the side is known to us and the other two sides are unknown to us. Okay, so n will be in this case 3. N dash is the total number of lines observed in both directions including the known side. ठीक है, n जो है वो हमारा है total number of lines. ठीक है, जो कि हमने including है जिसमें known side, और n dash है total number of lines observed in both directions. जैसे कि if in a triangle AB, ठीक है, ABC, there is a side AB, ठीक है. If AB is measured from A to B and B to A again, that this is what observed in both directions. ठीक है. So if all the lines in a triangle they are observed in both directions, then the n dash will be equals to 3 हो जाएगा. Now S is the total number of stations. Let's suppose in a triangle ABC there are 3 stations, so S will be 3. Now what is S dash? अब S dash है the number of stations occupied. ये कितने stations को आपने A को occupy किया है, B को किया है, C को भी किया है, जितने भी stations आपने occupy किए हैं, so S dash will be that. So once again, इसको repeat कर लेते हैं since we will be using this in the example. D over here is equals to the number of directions observed excluding the known side of the figure. ठीक है. N is the total number of lines including the known side in the figure. N dash is the number of lines observed in both directions including the known side. S is the total number of stations and S dash is the number of stations occupied. I will suggest कि आप इसको लिख लें ताकि जब हम इसको यूज करें एग्जांपल में तो आपके सामने ये चीज हो कि n dash क्या है, what is n, what is s, what is s dash. The next thing is the distance angle. Distance angle is the angle that is opposite to the known and common side of the first triangle and angle opposite to the common and required side of the second triangle. So if I can annotate on this and I can show you guys. Let's say this is a triangle, this is a quadrilateral in which we have two triangles A, B, C and A, D and C. Now he has told us that side AB, that is the known side, this side, this is known side. ठीक है जी. And required side हमारे पास क्या है, side CD. ठीक है. और in दोनों triangles में what is the common side, that is AC. So what is distance angle? Distance angle is the angle opposite to the known and common side of the first triangle. ठीक है. अब देखें यहाँ पे what is the known side, AB. AB, this AB is our known side. ठीक है. And common side कौन सी है, AC. So distance angle कौन सा हुआ, opposite to the known and common side. So opposite to the known side, the angle is 26. So for triangle ABC, the distance angles are opposite to the known side, the angle is 26 degree. 26, and opposite to the common side, angle क्या है 44 plus 56, that is 100. So for the triangle ABC, the distance angles are 26 and 100, right? Now, and angle opposite is the common and required side on this second triangle. अब second triangle में अगर देखें तो common side के opposite in triangle ADC, common side के opposite angle है 44 plus 68, so that is 112. So 112, and required side के opposite angle है 38, so 38. Now this is how can you determine the distance angles, and then using this distance angle you will be able to calculate the value of summation of delta A square delta A into delta B plus delta B square. ठीक है, this is how you can determine the value of the distance angles. Alright ji, next is the basically he has defined the entire process of the triangulation. So for that there are two phases, one is the field work and second is the computation that you do either at home or when you are in the field. अब फील्ड वर्क में हमारे पास क्या आता है, सबसे पहले रिकॉन्सेंस, वी ऑलरेडी नो दैट दैट इज अ प्रीलिमिनरी सर्वे इन व्हिच वी डू अ सर्वे, हम अपना रफ एस्टिमेट प्रिपेयर करते हैं, वी डिसाइड अ रफ अलाइनमेंट फॉर आवर प्रोजेक्ट्स, किस टाइप की मशीनरी किस टाइप का इक्विपमेंट यूज होना है, हम उसमें वो सारी चीजें डिस्कस करते हैं. वी हैव ऑलरेडी डिस्कस दिस थिंग इन द सर्वे वन. So fieldwork में reconnaissance है, erection of signals and post है at your control stations, measurement of baselines, right, and measurement of horizontal and vertical angles. Then we can perform the astronomical observations to measure the azimuths of the lines. We have already discussed the azimuth के angle from north. So uh, you must be familiar with this reconnaissance things. Let's just skip this thing and move further ahead. Signals and towers. So for that normally two types of signals use करते हैं, non-luminous signals और या luminous signals. ठीक है, depending upon whether we have to work in the day or night. ठीक है, ये different non-luminous signals given है, pole signal है, target signal है, pole and bush signal है, beacon है. So depending upon your type of work आप इस data को consider करते हैं. Now after measuring those distance angles you will come to this table. ठीक है, you can see in the horizontal and the vertical columns and both angles are given over there. At the top if you can see that there is a written over there values of delta A square plus delta into delta B plus delta B square. So once you have calculated the distance angles, now you can easily determine its value. Now up till here if you have any query you can tell me that.